It is the night of March 24th, 1945, on the eastern bank of the River Rhine near Rees, Germany. The air smells of diesel and wet earth. Somewhere in the darkness, 11,000 British and Canadian guns wait in silence, and on a low ridge behind them sits something that looks, at first glance, like an ordinary Matilda tank. It is not ordinary. Inside its turret, in place of a main gun, sits a sealed drum housing a carbon arc lamp burning at over 80 million candlepower, hot enough to melt the metal shutters that contain it if left open too long. A crewman checks his watch. At the signal, dozens of these machines, spread along a 5-kilometer front, switch on their lights at once. What happens next has no precedent in the history of warfare. A wall of blinding white light sweeps across the river, turning night into a strange, flickering false dawn. German defenders on the opposite bank, who moments before could see nothing, are suddenly unable to see anything at all, dazzled into total blindness while remaining perfectly illuminated targets themselves. Some of the lights flicker rapidly, deliberately, to make ranging by eye almost impossible. Shadows lurch and dance across the riverbank. To the men on the receiving end, it must have felt as though searchlights from some other world had been turned upon them. This was the Canal Defense Light, one of the most tightly guarded secrets of the British Army, and for nearly 6 years, almost nobody outside a small circle of engineers and senior officers knew that it existed at all. It would go on to take part in one of the largest river crossings of the war, and its story reveals just how seriously Britain took the idea that light itself, properly weaponized, could break an enemy's will before a single shot found its mark. To understand why anyone would build a tank whose main armament was a lamp, you have to go back to the trenches and the dark, exhausted years of the First World War, where night attacks were a gamble bordering on madness. Soldiers crossing no man's land after dusk could be cut down by machine guns they never saw, tripped by wire they could not detect, or simply lost in featureless black fields until daylight betrayed their position to snipers. Conventional searchlights existed, certainly, mounted on fixed emplacements for anti-aircraft work or coastal defense, but they were static, vulnerable, and useless for mobile ground operations. A searchlight bolted to a concrete bunker could illuminate the sky for a bomber crew far above. It could not advance with infantry, support a tank assault, or be repositioned in minutes if a battle turned against you. By the late 1930s, with another European war looking unavoidable, British military planners faced an old problem with new urgency. Armored warfare had transformed how battles were fought, but tanks were still essentially blind after sunset. Crews navigated by compass bearing and guesswork, units became separated in the dark, and entire offensives stalled simply because nobody could see where they were going, let alone where the enemy was. Worse, night was traditionally the defender's friend. An attacking force moving across open ground in darkness could be ambushed by machine gun nests it never spotted until the muzzle flashes gave the position away, usually a fraction of a second too late. Casualty estimates from night operations in the previous war made grim reading, and nobody wanted to repeat them. The challenge, then, was not simply building a brighter light. It was building a light powerful enough to illuminate a battlefield at distance, mobile enough to move with an armored column, and engineered cleverly enough that its dazzling glare blinded the enemy without blinding the very crews trying to operate it. On paper, this sounded almost impossible. No existing technology came close. The man most closely associated with solving this riddle was a wealthy eccentric named Marcel Mitsakis, a Greek-born inventor and businessman based in Britain, who had already made his fortune from headlamp and lighting patents. Working initially through his own company before the project was absorbed into official channels and developed further at the Royal Armoured Corps' experimental establishments, including trials overseen at Lowther Castle in Westmoreland, Mitsakis proposed mounting an immensely powerful carbon arc searchlight inside an armored turret, then projecting its beam through a narrow vertical slit rather than an open lens. This slit was the genius of the whole design. By restricting the light to a tall, thin aperture and shuttering it with a rapidly oscillating, Mechanism, engineers could produce a beam that flickered between roughly 6 and 12 times a second. To a human eye on the receiving end, this rapid flicker made it almost impossible to judge distance, range, or the precise location of the source, since the brain struggles to fix a position on something that keeps disappearing and reappearing. The crew operating the light, protected behind armor plate and viewing the world through narrow periscopes rather than directly through the beam, suffered none of this disorientation themselves. The lamp itself burned 2 carbon rods, similar in principle to those used in early cinema projectors but vastly scaled up, generating an arc so hot it produced light output measured in tens of millions of candle power, with most sources agreeing on a figure somewhere between 13 million and over 80 million, depending on configuration and distance from the lens. To put that in perspective, a single unit could reportedly be seen, or at least its glow detected, from many kilometers away, and at closer range the dazzle effect was said to be comparable to staring directly into a welding torch, only considerably larger and impossible to look away from quickly enough. The whole apparatus, lamp, shutter mechanism, projector housing, and turret was built to fit inside a standard Matilda II infantry tank turret in place of its gun, with later variants adapted for Grant and Sherman chassis as well. The conversion required stripping the tank of its conventional armament entirely, since there was no room for both a cannon and the bulky lighting equipment, which meant Canal defense light tanks were essentially unarmed offensively and relied entirely on supporting units for direct firepower. Manufacturing took place under conditions of extraordinary secrecy. The project was given the deliberately bland and misleading code name Canal Defense Light specifically so that anyone who overheard the term, including most of the soldiers who would eventually crew the vehicles, would assume it referred to mundane lighting equipment for guarding canals and waterways rather than an offensive weapon designed to blind enemy forces at the point of attack. Conversion work was carried out at sites including a converted factory complex, with crews trained in isolated locations and sworn to silence under threat of court-martial. Production numbers remain difficult to pin down precisely, since official records were deliberately kept sparse and much documentation was destroyed or never declassified in detail. But historians generally estimate that somewhere between 300 and just over 1,000 vehicles were converted across the various marks, a remarkably large investment in a weapon that almost nobody was permitted to know existed. If you are finding this interesting, a quick subscribe helps more than you know. For most of the war, the Canal Defense Light sat largely unused, its crews training in remote corners of Britain and North Africa, while commanders debated when, or whether, to risk revealing its existence. The fear was straightforward. Use it once, and the enemy would immediately understand what they were facing and begin developing countermeasures or simply adjusting tactics to neutralize the dazzle effect. Some units, training under the cover name Gizmo, or simply referred to obliquely as searchlight troops, waited years for their moment. Limited use is documented in Italy during the advance up the peninsula in 1944, and at the crossing of the Rhine in Operation Plunder during March 1945, the weapon finally saw its largest deployment, with lights used both to illuminate crossing points for engineers and assault troops, and to dazzle and disorient German positions on the opposite bank during the advance toward Rees and Wesel. Accounts from the operation describe an eerie, artificial twilight settling over the battlefield, with some witnesses comparing the effect to a perpetual, flickering lightning storm that never quite resolved into anything the eye could properly process. Exact tactical outcomes attributable to the light alone are difficult to isolate from the broader weight of artillery, smoke, and air power used during the same operation, and many historians caution that its psychological value likely exceeded its measurable military impact. But contemporary reports from troops on the ground consistently describe German defenders as confused, suppressed, and unable to return effective aimed fire during the critical opening hours of the crossing. By comparison, German efforts in this specific field never matched the ambition of the Canal Defense Light. Germany experimented with vehicle-mounted infrared systems, including the Sperber and Uhu devices intended to give tank crews and infantry night vision. Hi, I'm excited you're here. This is a preview capability through active infrared illumination paired with detector equipment, a genuinely advanced approach for its era, but one that required cumbersome receiver units and offered no dazzling or disorientation effect against an enemy who simply could not see the infrared light at all. It was, in essence, solving a different problem, helping your own side see in the dark rather than denying the enemy the ability to see anything. American forces, meanwhile, showed interest in the British design and even trialed their own version mounted on Grant tanks, but never deployed it at the scale or with the operational secrecy that characterized the British program, and No Axis Power developed an equivalent system using visible light and rapid shuttering for direct battlefield dazzle. In raw light output, nothing else fielded by any combatant nation came close to matching the Canal defense light's combination of brightness, mobility, and protected operation. Assessing the true legacy of the Canal defense light remains genuinely difficult, precisely because the secrecy that defined its development also limited its use, and limited use means a thin evidentiary record. What is clear is that it represented a distinctly British approach to the problem of night combat, favoring an ingenious mechanical solution to a tactical problem over the more conventional infrared technology pursued elsewhere, and that its psychological effect on troops, both friendly and enemy, was by most accounts considerable even where its material destructiveness was limited, since the weapon fired no shells and killed no one directly. Surviving examples are rare, but not extinct. Preserved Canal defense light turrets and at least one complete converted tank can today be found in British military museums, including collections associated with the Tank Museum at Bovington, where visitors can see the narrow projector slit and shuttering mechanism up close and get some sense of just how strange this machine must have looked rolling forward in the dark. Its influence on later night fighting doctrine is harder to trace directly, since post-war militaries largely moved toward image intensification and infrared systems rather than brute force visible dazzle. But the underlying principle, that disorientation can be as valuable a weapon as destruction, would echo forward into later generations of flash and stun technology used by armed forces around the world. Return, for a moment, to that ridge above the Rhine on the night of March 24, 1945. Picture the carbon arcs igniting in sequence along 5 kilometers of riverbank, the shutters beginning their rapid, deliberate flicker, the false dawn rolling out across water that should, by every natural law, have remained dark for hours yet. On one side of that light stood men who understood exactly what was happening, trained for years in conditions of total secrecy, protected behind armor plate, watching the battlefield unfold through narrow slits of toughened glass. On the other side stood men who understood nothing at all, who saw only a blinding, pulsing, incomprehensible wall of brightness where the enemy was supposed to be invisible. That asymmetry, knowledge against confusion, certainty against disorientation, was the entire point. The Canal defense light never fired a shell. It never needed to. It simply took away the one advantage darkness had always given to soldiers on a battlefield, the ability to hide, and in doing so it turned an ordinary night on the Rhine into something closer to a waking nightmare for the men caught in its glare. Britain built a weapon out of shadow itself, kept it secret for the better part of 6 years, and unleashed it exactly once, at exactly the moment it could do the most good. Few inventions of the Second World War demonstrate quite so clearly that the most effective weapon is not always the one that kills. Sometimes it is simply the one that makes an enemy unable to thin.